Hey everybody, welcome back to Econ 100B. This is an asynchronous lecture that I'm going to use to go over the midterm, go over some questions that people had problems with on the multiple choice section, and then I'll go point by the short answer section, solve everything, and talk about that generally. And hopefully that'll be a nice little review, and then we'll talk about where we're going forward. So let's get into it. Overall, people did really well with the multiple choice problem. There was one problem where there were two answers. There was a mistake in entering the multiple choice questions. Question 5 asked you to solve for an equilibrium price, and there were two answers that were number 10 or $10. I've gone through now and manually fixed it so that everybody who put in $10 got that point, got those points. It actually raised the average from 80% for the class to 82%, so that's kind of cool. On average, the multiple choice portion took about 55 minutes, and people had a full range of scores from 50% to 100%. So people did really well on that. I'm still grading the short answer problems, but generally it looks like everyone did really, really well. So congratulations, right? Halfway there. Going through the multiple choice questions, I'm just going to look at the ones where a third or more people got the problem wrong and talk about those. And hopefully this functions as a little bit of a review of the stuff we've gone over so far, since we'll have taken a bit of time off from learning together. So one of the problems that people had a question about was a demand function for pizza. So I'm going to go ahead and write the demand function out, and we can talk about it a little bit more generally. So we have the demand function for pizza is given as Q equals 1.3 minus 0.45 P plus, you know what, I didn't give myself enough room. I'm going to start over. Okay, so the demand function is Q equals 1.3 plus 0.45 price of pizza plus 0.72 the price of burritos and 1.16 times income. And so this is a demand function where we can see that the demand for pizza is a function of the price of pizza, the price of burritos, and income. We want to remember when we think about our determinants of demand, price is a determinant of demand, and that's going to give us changes in quantity demanded. So a change in P is going to give us a change in Q. These other factors, income and the price of a related good, those are those non-price determinants that can shift the demand curve out or in. So the first question asks you, given the coefficient for PB, can we say that burritos are a complement for pizza, a substitute for pizza, an input for pizza, or in a different market for pizza and therefore unrelated? So the first thing is, yeah, they're in different markets, but they're related because the price of burritos is part of the demand function for pizza, so they are related. That leaves the question to be, is it a substitute good or a complement good? And if increasing the price of burritos is going to have a positive effect on the quantity demanded of pizza, that means that they are substitutes. As the price of burritos goes up, consumers are going to demand more pizza because it's relatively more affordable. So that tells us that it's a substitute good. The next question asks about the coefficient for income, Y. And this, remember when we solved for the effect of a change in Y on a change in Q, what we would always find is that this coefficient is the size or the magnitude of the effect of a change in Y on a change in Q. The first thing we want to see is it a normal good, an inferior good, a Giffen good, or the demand function for pizza is not a function of income? It is a function of income. Income affects consumption of all goods, right? That's why we have income elasticity of demand. So as income goes up, how is the quantity of demanded of pizza affected? That's what this question is asking. If the coefficient for income is plus 1.16, that tells us that as income goes up, we see the quantity demanded or the demand for pizza go up. So that tells us that it is a function of income. It is not an inferior good. It's definitely not a giffen good, a good that violates the law of demand. It's a normal good. It's a good for which we expect consumers to buy more of as their income goes up. Most things, when your income goes up, you buy more of them. The last question asks, if the price of pizza increases, what is going to happen to demand for pizza? We're going to see, or is it going to be a supply increase, demand decrease, an income increase, or a decrease in quantity demanded? So in this case, if we see a change in the price of a good, that's going to result in a change in the quantity demanded of that good, right? Remember, this is going back to your Econ 1B. If we've got our market for pizza here, we've got some demand, a change in income, or a change in the price of burritos would shift the curve out or in, right? How a change in the price of pizza itself, that's not a non-price determinant. That's going to actually move us if the price, say, what did we say? We said the price was going to increase. So let's start out here in some general spot where we've got some quantity of pizza and some price of pizza. If the price goes up, that's going to move us along the curve, right? That's going to be a change in quantity demanded. Okay, so hopefully that makes sense and is familiar. The next question that people had a little bit of difficulty with was another question along these lines. I think part of it is that we went over a lot of material in the first 7 weeks of class, and so the supply and demand stuff might not have been as fresh in your mind, but we want to remember, so it's asking what factor might shift the supply curve out for a firm. And so we want to see what factor would shift supply out for a firm. And so let's put in a supply curve and think about that. So we have supply for some firm, and we want to know what's going to shift that supply curve out. We have an increase in government regulations and taxes. That's not going to shift supply out. Remember, if we shift supply out, what we're doing is increasing the quantity supplied at every price. So if this is our P star, this is Q star 1, shifting it out is going to move us out to a higher quantity, right? If we see an increase in taxes and government regulations, that's not going to make it cheaper or easier to produce goods and services. That would probably shift the supply curve in. An increase in the number of consumers in the market, that's a demand determinant. It's a non-price determinant of demand. It's not going to directly affect supply. A decrease in the cost or in the price of the good, again, that's movement along the curve. When you change the price of the good we're talking about, that's just movement along the curve, a change in quantity supplied in this case. The correct answer is a decrease in the cost of production. If it gets cheaper and easier to produce something, that's going to shift that supply curve out, increasing the quantity at every price or lowering the price at a given quantity. Okay? Hopefully that makes sense. It's again that should be something that you remember from 1B, but if not, that's something that should be pretty easy to review. The next question was that demand function, supply function, where you solve for the equilibrium price. Everyone got that right. So do make sure you got your points on that. If you didn't, let me know immediately and I'll take care of it. Let's see. Government intervention can move a market to disequilibrium. How would a higher minimum wage affect the market for labor? So let's take a look at the market for labor and work that out real quick. Think about the market for labor and a minimum wage as being a price floor, a limit on how low how low a wage you can offer, how little you can pay for somebody's labor. So we've got wage up here, we've got the market for labor, and we've got some supply and demand curve for labor. Right? So we've got some supply and demand curve, we've got our equilibrium quantity of labor and our equilibrium wage. Now, if we impose a minimum wage that is above that equilibrium, let's say, so we have a higher minimum wage, that's going to lead to more workers wanting to enter the labor market and fewer employers wanting to hire. So what we would have is quantity supplied of labor is greater than quantity demanded. That's another way of saying we would have increased unemployment or a labor surplus. So if we have a higher minimum wage, it's not going to tend to reduce the disequilibrium unless the minimum wage was unless the equilibrium wage was, well, it wouldn't unless, if we were in equilibrium, moving to a different wage would never reduce the disequilibrium, right? If we have a higher minimum wage, it's not going to result in excess demand or a shortage of labor. We have less demand because labor got more expensive. It wouldn't move us to the equilibrium unless we were somehow already in disequilibrium. What it would do in most cases in every standard example is if we have a higher minimum wage in the market for labor, it's going to result in that excess supply, a labor surplus, or increased unemployment. So elasticities, everyone did a really good job on. What does a steeper curve imply? A steeper curve implies less sensitivity to price. Let's look at it right in here. Show you, we've got, let's say, some good that we're talking about. If we have a very steep curve, let's say it's a demand curve, then we're going to tend to see that a change in price from P1 to P2 has a small effect on quantity demanded, right? That's not very sensitive to a change in price. If instead we have a much flatter demand curve, now that same change in price from P1 to P2 is going to have a much larger effect on quantity demanded. So flatter curves, whether it's supply or demand, are going to be more elastic, more sensitive to price. Steeper curves are going to tend to be less elastic, less sensitive to price. And that's true for demand and supply. Let's see. Another question that people had a problem with was a graph that I'm going to show you right now on the screen. Hold on. So here, this question asks you to look at this graph and determine what it says about market demand. So the first question is moving from P1 to P2 will tend to have what effect on revenue? And what you want to do here is remember, revenue is price times quantity. So we're going to compare P1 and Q1 to P2 and Q2. P1 revenue is A plus B, and P2 revenue is A plus C. So if you want to answer this question, you just ask which is bigger, B or C. And I think B is obviously bigger. So if we move from P1 to P2, what is the effect on revenue? Are we going to see an increase in expenditure, an increase in tax, an increase in revenue, or a decrease in revenue? The answer is a decrease in revenue, right? Revenue for this is going to, for the company here, is going to tend to decrease because of the flatness of the curve. Because it's a very elastic demand good, we're going to see that small price change is going to have a big effect on quantity demanded. So raising prices is going to really reduce the quantity demanded. Question B says, what can we say about the demand curve given the effect of the move from P1 to P2? Again, it's relatively elastic, right? It's not perfectly elastic, it's not perfectly inelastic, and it's not relatively inelastic. It's also a demand curve and not a supply curve. So what we're seeing here, we don't see the supply curve. We have no idea what the supply curve is. What we know is we moved from E1 to E2 when we went from P1 to P2, and that price increase resulted in a very large change in quantity. So we had a small change in P and a large change in quantity demanded. That's relatively elastic, okay? Hopefully that makes sense. The next question that people had some difficulty with, some people had some trouble with, was this question about using one of our examples from class of looking at a consumer who has preferences for burritos and pizzas. We have a budget constraint here, an indifference curve here, and an optimal bundle E here. The first question says, what is not true about this graph? Well, let's see. The utility maximizing bundle of goods includes both pizzas and burritos. Yes, that's the utility maximizing bundle. It includes some quantity of burritos and pizzas. That is true. The model has an interior solution. Yes, remember, an interior solution is not a corner solution. A corner solution would be all burritos or all pizzas. An interior solution is anything in between those two endpoints. See the next problem, or the next response, the consumer views burritos and pizzas as perfect substitutes. That's not true. If it was, they would have different indifference curves. If they were perfect substitutes, the indifference curves wouldn't be bowed like that. This shape here tells us that there is a difference in the relationship between consuming burritos and pizzas, and that our consumer, as they consume fewer burritos, is willing to trade more pizza to get more burritos, right? There's a difference in the marginal rate of substitution along the indifference curve. So they are not perfect substitutes. They're also not perfect complements. They're in between. Most goods are. And so that is what is not true about this graph. At point E, the consumer is maximizing utility. That's accurate, right? It is clearly an indifference curve that is tangent to that budget constraint. We're assuming it's the highest possible indifference curve. I can't imagine mathematically a higher indifference curve that would still be tangent to that budget constraint, knowing that these indifference curves are going to hold their shape and not cross, right? So that is number one. Number two says an increase in the price of pizzas will have what effect on the graph above? So if we see the price of pizzas go up, what's going to happen is the same amount of money buys fewer pizzas. So we're going to see that budget constraint shift in. And let me show you what that would look like, right? If we've got our burritos and pizza consumer, no matter where we are, what is it, 25 and 50 on this graph, if we move from here, if we see the price of pizzas go up, an increase in the price of pizza is going to mean our consumer can buy less pizza given their income. So it's going to rotate that graph in. It's not going to change the maximum quantity of burritos that can be purchased, but it will change the maximum quantity of pizzas that can be purchased. So it's going to rotate that budget constraint in. There we go, like this. Okay, so an increase in the price of pizza will rotate the budget curve in to reflect higher prices. It will not change the slope of the budget constraint. It will not rotate the budget constraint out, and it definitely will affect the budget curve, because if you think about it, if you have $100 to spend and the price of stuff you buy goes up, that affects your budget. That affects what you can buy, right? Answer 3 says an increase in income will have what effect on the graph? So this is a totally different scenario. If we're increasing income, then the price of these two goods didn't change. Instead, what changed was my income went up. So that's just going to shift the curve out, holding the slope constant. So a change in income moves you out. It's a shift, holding the slope constant. A change in price is going to rotate depending on whether it's an increase or a decrease. So hopefully that helps. Okay. The next problem I wanted to talk about was this one, the curve that shows the relationship between income and quantity demanded. That's the angle curve. Remember, we derived those after we talked about budget constraints. We derived those looking at how, first we derived demand curves. We said, okay, if we take basically did this, right? We took a budget constraint and then we changed the price of a good up and down. And then that led to our derivation of demand curves, right? So if we take away the purple part and we just change the price of pizza a bunch of different times, now we can lower the price of pizza and raise the price of pizza. That's going to give us different bundles of pizza. That's going to tell us, okay, so if the price of pizza goes down, we buy more pizza. As the price of pizza goes up, we buy less pizza. Wait, that's not right. When the price of pizza is low, we're going to consume a little bit more pizza. So maybe this is our first constraint. This is our second one. And this is our third one. So we're going to have these points that show us that as the price of pizza changes, our demand for pizza changes. That was the demand curve. The angle curve says instead of looking at changes in the price of pizza, now let's look at changes in income. So maybe this is one level of income. This is a higher level of income. And maybe this is some lower level of income here. And now we're going to see how, as we move along, look at these different budget constraints, how we see differences in consumption at different income levels. So when the income is higher, we're going to expect to consume a larger quantity of pizza, and as income goes lower, we consume less. That is our angle curve. Let's use this color. So that's what that curve is called. Angle curve is the curve that shows the relationship between income and quantity demanded. Remember, demand curve shows the relationship between price and quantity demanded. That's how we derive that. The last question I wanted to look at was, I wanted to look at this question here. So this looks at the short run production function for a firm that is Q equals 10L plus K. If the wage rate for a unit of labor is $10, then I want you to calculate the average variable cost. So again, remember what average variable cost is. Average variable cost is variable cost divided by quantity. If the variable cost is really just the wage, or $10, then we want to look at the production function, Q equals 10L plus K, to see how much labor we have to add to get one more unit of Q. And that's where we get the tricky part, right? When I change L by 1, 10 times 1 gives me a change in Q of 10. So if my variable cost is $10, it's my change in wages when I have one additional unit of labor. The change in Q is also going to be 10 because I have added one more worker 10 times, or one more unit of labor. 10 times 1 gives me a change in Q of 10. 10 divided by 10 is 1. Hopefully that kind of makes sense and you see that. Other problems, the law of diminishing returns, diminishing marginal product, holds true only if we hold technology and other inputs constant. That's true. It can also be considered true that it's relevant for firms facing decreasing returns to scale. Because the reality is, if you're at a point of diminishing or decreasing returns to scale, then you're probably facing diminishing marginal product or diminishing marginal returns. So for the people who did choose that option, I'm going to go ahead and give you your points for that one. I'll go through and make those changes for the people who responded to that one. It can be avoided by changes in technology, and it doesn't only affect labor in production, it can also affect capital. It can affect any input, really. Sunk costs, pretty much everybody knew that sunk costs are no longer calculated as implicit or explicit costs. They cannot still be considered an opportunity cost. They are not explicitly describing a durable good, and so not all of those options are accurate. When costs are sunk, we don't consider them an opportunity cost anymore because they can't be reclaimed. That's it. Which of the following is not a way firms can minimize costs? The Cobb-Douglas rule is not one of the ways that the firms can minimize cost. We can use the lowest Isocost rule, the last dollar rule, or the tangency rule. Those are the three ways that we can calculate a cost minimizing production bundle for a firm, right? Getting that Isocost curve tangent to that isoquant curve. So now, hopefully, we are ready to talk about these short answer problems. Okay, now for the short answer part, I'm going to go ahead and use my dot cam and a piece of paper because there's a lot of little graphing and math, and I think that is the best way to do it. So let's go ahead and do that. Okay, so the first part asks you to look at a firm that produces pens that faces a wage of $15 and rent of $10. The fixed cost function is known as wage times labor plus rent times capital, where costs are fixed at $850 a week. So we want to derive the capital labor ratio as a function of how much capital is used given the amount of labor used. So that is pretty easy to do. We can use the formula that I gave you in the hint and just say, solve this for K in terms of C, W, L, and R. That's going to be K equals C bar over R minus wage over rent times L, which in this case is going to be K equals 850 divided by 10 minus 15 divided by 10 times L, which simplifies down to 85 minus 1.5 L. Pretty straightforward. And then I ask you to graph the Isocost curve. And what we want to remember here is that this is parallel to everything we did in consumer choice. We're just looking now at the firm version where we're still looking at a constraint instead of a budget constraint, it's a cost constraint. And then we're looking at a consumption bundle, but rather than looking at consumption of goods like households do, we're looking at consumption of labor and capital in a combination to produce a certain level of output rather than a certain level of utility. So we know we're going to want to graph our Isocost in labor and capital space. So we want to put capital here and labor here. And we also want to remember that when we're solving for these endpoints, that they're going to be equal to the total cost, $850, divided by the cost of renting capital for capital, and the cost of renting labor or the wage for for labor. So that means that I can go ahead and take $850 and divide it by the rental rate of capital 10 to get my endpoint here of 85. And if I want to find my endpoint for labor, it's going to be $850 divided by the $15 wage rate, which ends up being the very awkward number of 56.6 repeating. So I'm going to call it 56.67. And then that gives us our isocost curve. We want to remember that we could also go through and use this formula to solve for different levels of capital and labor. So things like if I wanted to go through and see, okay, if I use L equal to 10, what is my capital going to be? So that's going to be K equals 85 minus 1.5 times 10 is going to be K equals 85 minus 15 equals 75. And that's going to give me points along this curve. So at a capital rate of, if I use 75 units of capital, I'm going to use 10 units of labor, and so on. Does that make sense? And then we could go through, and if we wanted to, plot based on the marginal productivity of capital and labor based on a given production function, we would then find the isoquant tangent to that isocost, right? And that's one of those rules that we can use to find that. So that's part one. That's number one, parts A and B. Part two gets a little bit more complicated. So for part two, we're going to be looking at the consumer preferences side of things. I'm going to just slide this up a little bit here. And we start out with a consumer, Jana, who consumes two things, food and stuff. And so we can already know if we have food and stuff that her income constraint or budget constraint is going to be her income. And that's going to be spent on either food at price F or stuff at price S. And we get that she has a weekly budget of $500. The price of food is $5 and the price of stuff is $10. And so what we need to do is derive the utility, we have her utility function, which comes from her consumption of food and stuff, and that's given as F 0.4 S 0.6, right? And so from there, what we're going to want to do is start by graphing her budget constraint. And so the first thing we want to do when we graph her budget constraint is we want to remember that we're going to be looking at her consumption of two different goods, right? And let me move this down a little bit more. Does that work? Yeah. Okay. We're going to put stuff on the y-axis and food on the x-axis. And then again, we're going to calculate those endpoints, and those endpoints are going to be given by how much food she could buy if she spent her entire income on food. So since her income is $500, if she spent all of it on food, we would find 500 divided by 5 is going to give us total consumption of food of 100 units. If she spends all of her money on stuff, it's going to be that $500 spent on stuff. Stuff costs $10, so 500 divided by 10 is going to give us the end point over here of 50 units of stuff, right? And then we want to label at least 3 consumption points. So let's also see what would happen if she spent $250 on food and $250 on stuff, right? So we'd be spending our entire income, all $500, on half on food, half on stuff. So then we do the same thing. We divide by the price to get the quantity that she could consume in that, given those prices. So if she could spend $250 on stuff, that's going to be 25 units of stuff. $250 on food at $5 a unit, that's going to be 50 units of food. So that gives us now 3 points, and I'm going to go ahead and draw that sort of in a straight line budget constraint. Sorry. That's sort of close. And there's our third point. And you can pick whatever point you want. I like the midpoint just because I feel like it's a good reference point. So now we have part A. We have derived Jana's budget constraint with stuff on the y-axis and have labeled 3 possible consumption points. Part B is where it gets tricky. For part B, we want to solve for the optimal consumption point E, right? And that's going to be given the fact that Jana wants to maximize her utilities subject to the prices of food and stuff. So what we want to do then is set the marginal rate of substitution, which is the slope of her indifference curve, equal to the marginal rate of transformation, which is the slope of the budget constraint. Remembering that the slope of that budget constraint is the ratio of the 2 prices, right? The ratio of the 2 prices gives us the slope of the budget constraint. So what we can do here is we could say that the slope of the budget constraint is going to be negative PF divided by PS. And we're going to want to keep that in mind when we solve our problem here. We also want to remember what the slope of the indifference curve is. Remember, there's a whole set of indifference curves, a map of indifference curves for every consumer, and they're going to have the same shape because they're going to be based on the marginal utility of the 2 goods, the marginal utility associated with food and stuff. And we want to find the utility curve that is at the highest possible consumption point, but tangent to the budget constraint. And so that's why we want to set those 2 slopes equal to each other. The slope of the marginal rate of the slope of the indifference curve is the marginal rate of substitution is equal to MUF divided by MUS. And we want to set that equal to the marginal rate of transformation, or the slope of the budget constraint, which is PF divided by PS. And so we can go ahead and solve that. We can remember that the marginal utility of F over the marginal utility of S is equal to, when we're using a Cobb-Douglas production function, it's going to make it easier for us to solve this. We can set it equal to the coefficient for F, which is 0.4, over the coefficient for S, 0.6, times S over F. And that's because of this Cobb-Douglas production function, so we can take those 2 exponents and the quantities of those 2, and that'll help us solve this problem. So I take this back down here, and now I've got 0.4 S and 0.6 F. So 0.4 over 0.6 times S over F is equal to PF, which is 5, over PS, which is 10, which gives us 0.4 divided by 0.6. S over F is equal to 5 over 10, or 2/3 SF is equal to 1/2, or I'm running out of space. S over F is equal to, and I can just divide both sides by 2/3 and get 0.75. S is equal to 0.75 F. Do you see how I did that? So basically taking this and then just solving it algebraically, setting these two equal to each other, and then solving it algebraically. Here's the other thing, though, that you can do, is you could do the same thing we did above here, where we solved for the capital labor ratio, right? We can do the same thing with the budget constraint, and I'll show it to you on another sheet of paper. So let's start over again. Let's take this out and restart this problem. And that's the cool thing about this, is there are lots of ways to solve these problems. So we started out with our budget constraint, FPF plus SPS. And I know you probably think I'm being redundant, but I think it's really important to keep track of all of your elements in these and restate them, because it can be really easy to make a simple mistake and make a mix up the prices or something. So I like to always go through and state the conditions of the problem. So we've got food, we've got stuff. Our endpoints are 500 divided by 10 and 500 divided by 5. I also had an endpoint that was, or a midpoint. I'm going to redraw that budget constraint. Oops, and I got so much closer to a nice one this time. Not quite perfect, but about there. And then we wanted to solve for the utility maximizing quantity. And so the one way we could do it is set marginal rate of substitution equal to the marginal rate of transformation, which gave us 0.4 over 0.6 times S over F equal to 5 divided by 10, which was 2/3 SF equals 1/2, or S over F equals 0.75. S equals 0.75 F. Here's the other thing we can do. If we take our budget constraint and solve for F in terms of S. So we have 500 equals F times $5 plus S times $10. We can go through and use our utility function to help us understand how to solve this problem. And this actually comes from one of the homework problems that we did. In Chapter 4, Homework 14, we went through a utility function that was a Cobb-Douglas like this, and we solved it by using an equation where we said the optimal quantity of food in terms of stuff can be given by the coefficient for food times the budget divided by the price. And so what we're saying here is the optimal quantity of food is a function of the marginal utility associated with it, the budget available, and the price for that good. And so 500 divided by 5 times 0.4 gives us 40. For stuff, it would be the coefficient for stuff, 0.6, divided by, or times 500, our income. Oops, there it is. Divided by the price of stuff. 500 divided by 10 times 0.6 is 30. And we can check it over here by saying, okay, if I have S equals 0.75 F, and instead I insert 0.75 times 40, I get 0.75 times 40 is equal to 30. You see that? So we're getting the same outcome in either case. We can also go through and solve using the budget constraint another way. We can say, okay, let me see if I can use another pen here for another way to solve this. We can take this 500 F5 plus S10 and insert this into this. So if we have 500 equals F times $5 plus S, which is 0.75 F times 10, what we've done here is we've said that this is S equals 0.75 F. And then we just go through and solve it algebraically. So 500 equals F, 5 times F, plus 0.75 F times 10 is going to give us 7.5, F. Duh. And then 7.5 F plus 5F is going to give us 500 equals 12.5 F. Divide both sides by 12.5, and we get 40 equals F. So I know this is a challenging problem, but this really is the core of what we've been learning so far in terms of consumption, consumer choice, solving for utility maximizing bundles, and this translates to the firm behavior stuff, because instead of using a utility function and a budget constraint, we would be using a cost function and an isoquant, right? So they're truly parallel, right? It's exactly the same thing. We see the same general form here when we look at the cost and the cost function. Here's the budget constraint. They're very similar. We would have a production function that would be really similar to this utility function, and we could solve for them the same way by setting the two utility curves or the two curved slopes equal to each other. Either way, however you get to it, we end up with an optimal consumption point that is 40 units of stuff and 30 units of everything else. Oops, there we go. And so part C says to graph the utility curve that's tangent to that budget constraint. I'm going to label it I, and I'm going to label that consumption point or that consumption bundle E. Okay? So hopefully once you've got that, that's pretty simple. And then the last question, question D, so you can see that there. Yeah. I'll solve D up here so it's all in one spot. Question D says, okay, if the price of stuff decreases to $5, what happens to her budget constraint? What happens to her utility? Graph the new budget constraint and speak generally about the effect on Jana's utility. So the price of stuff is going to go down from $10 to $5. So the price of stuff is now $5. That means that Jana can buy more stuff. Remember, we calculate that endpoint by taking y divided by PS. When it was 10, we got 50. Now we're going to get 100. It's going to rotate that budget constraint out to the point where she can now consume more stuff. So the first thing that's going to happen is we're going to see the budget line or the budget constraint rotate out so that she can have the maximum consumption of stuff equal to 100. What does that mean for her utility? Well, you can talk about it generally. I'm going to go ahead and just make a mess of my graph by grabbing a highlighter if I have one. I don't think I do. I'm just going to draw the effect. And so what we want to think about is the fact that we started out with her, all the possible consumption that she could have was everything in this triangle here, right? This is her maximum consumption point along this budget constraint. And these are sort of her options, is this little triangle here beneath her budget constraint. When we see the price of stuff go down, now this is her budget constraint. First of all, she's going to be necessarily on a higher indifference curve. She's going to experience higher utility because all of these consumption bundles in this triangle are now available. Right? She can consume all of these bundles of goods, all these combinations, all these combinations of goods, these consumption bundles are now possible. We can imagine a world where she'd probably be on a higher indifference curve. Maybe we call that indifference curve 2 instead of indifference curve 1. And so we would see her be better off. It's going to change the slope of the curve, right? Now we're going to see the slope of the budget constraint is no longer going to be negative 5 over 10. It's going to be negative 5 over 5 or negative 1. And so we're going to see that show up too. It's going to make our consumer better off. Lower prices make our consumer better off. Sound good? Make sense? Hopefully? Okay, sounds good. Let me know what questions you have. I know that was a difficult one, but I think it's a really, really useful problem to help understand exactly what all we're talking about and what all the goals of these last few chapters have been. The last question looks at firm behavior stuff and says, okay, given that we have some information about firm costs, calculate the rest of the information and then graph the cost curves. So we start out with fixed cost, variable cost, total cost, and then we need to find average variable cost, average fixed cost, average cost, and marginal cost. And we have quantities going from 0, 1, 2, 3, 4, and 5. Fixed costs are $10 all the way down. Variable costs start out at 0 for nothing, and then we'll go up to $6, $8, $15, $24, and $35. And then total cost is going to be fixed plus variable. So 10, 16, 18, 25, 34, and 45. Hopefully this isn't too challenging because this should be somewhat familiar. This is stuff that we saw in Econ 1B, and it should be some stuff that you've experienced. This isn't the most complicated part of this stuff, right? So average variable cost, remember, is going to be variable cost divided by quantity. So we have no value here, and then we start with variable cost. 6 divided by 1 is 6. 8 divided by 2 is 4. 15 divided by 3 is 5. And then we have 24 divided by 4 is 6. And 35 divided by 5 is 7. Average fixed cost is fixed cost divided by quantity. So we have 10 divided by 1, 10 divided by 2, 10 divided by 3, which is 3.3 repeating. 10 divided by 4 is 2.5. 10 divided by 5 is 2. And then average total cost is going to be just total cost divided by quantity. So again, we start out with 16 divided by 1, 18 divided by 2 is 9. 25 divided by 3 is 8.3 repeating. 24 divided by 4 is 8.5. And 45 divided by 5 is 9. And then marginal cost is just the change in total cost divided by the change in quantity. We're going to see quantity change by 1, and so we're just looking at the change in total cost. As we move from 0 to 1, we see total cost go from 10 to 16, so that's going to be $6. From 1 to 2, total cost goes from 16 to 18, so that's $2 in marginal cost. From 18 to 25, that is $7. From 25 to 34 is $9. And from 34 to 45 is 11. Hopefully that's straightforward and not too complicated. Let me put these up here too, just in case. But hopefully that all makes sense and wasn't too complex. The next part I ask you to do is graph the cost curves. Graph average variable cost, average fixed cost, average total cost, and marginal cost. So let's do that together. So that's A, B, we have the quantity for a given firm, the costs associated with it. And we top out at about $20. So let's say that's 10, that's 15, that's 5. Okay, and then I want to go ahead and let's start with average variable cost. So average variable cost is going to be starting out at the first unit at $6. Second unit is $4. Third unit is $5. Fourth unit is $6 again. And then the fifth unit is $7. So our average variable cost curve looks like that. Our average fixed cost is always following. We start out with average fixed cost of $10, and then we drop down to 5, and then 3.3, and then 2.5, and then 2. And so that gives that relationship. That's not necessarily the most important curve. The curves we really care about are average variable cost and what's coming up next, average total cost. That starts out up here at 16, then 9, then 8.3, that's there, then 8.5, and then finally back up to 9. That's about right. Last but certainly not least is marginal cost, and this is going to help us answer part C. We want to go ahead and graph marginal cost. Some people say it's really important to graph marginal cost in between. So for example, this would be between 0 and 1, and so you would graph it right here. Marginal cost of 2 is between 1 and 2, so you would graph it here. I don't think it's the most important thing. I'm not super picky about it. And so I'm just going to graph it on the 1. So the first is going to be about like that. That's marginal cost point of $6 for the first unit. 2 is $2, which is about here we're saying. 3 is $7, which is about here. Well, maybe more like this, right there. 4 is $9. And I'm kind of trying to use these other points as reference points so it makes sense. So that's 9, so that's 9. And then 5 is $11. And so that's going to be, I guess that's 9. And then 11 is going to be here. So that's going to go like this. A little bit wobbly, but the general shape is there. We see the increasing returns to scale as marginal costs are falling, and then marginal costs start to rise as we see the diminishing returns, the changes in returns to scale. And then the last thing we want to do is indicate on the graph the point at which average cost is minimized. And this is important because remember, average costs are minimized at the point where marginal cost crosses. And that's because here, for this point to here, from producing a quantity of 1 to say 3, we see average costs are falling, right? Average costs are going down, going down, going down, and now they're going up, and now they're going up. And that's because that's where, and that's why where marginal cost crosses average total cost, we're going to see average total cost be minimized. And we can see the same effect over here with where average variable cost crosses average marginal cost, or crosses marginal cost. Marginal costs are 6, and then it goes down, and then it starts to go up again. And this is an earlier point than when it crosses total cost. It's over here when they cross somewhere between 2 and 3, right? So the answer is that average cost is minimized at a quantity of 3 or where marginal cost is equal to average cost. Okay? And that's because that's important for us. That's important for us to know because that's where we're going to see efficient scale take place. It's going to tell us more about where a firm is best off. Make sense? Hopefully? Hopefully this was a little bit of an easy part, and the big idea here comes from this idea that, costs are falling here up until this point, and then from here on, costs are rising. Okay? Okay. So that is the midterm review. Let me know what questions you have about that. Okay? So that's the midterm. Hopefully it makes sense. Hopefully you remember it since it's been a little over a week. And hopefully going over those problems is a nice little review of everything we've done so far. Going forward, we're going to start with Chapter 8 next week, looking at competitive firms and markets, looking at how firms behave in a competitive market. We're going to look at firms maximizing profit, competition in the short run and the long run. And doing that, we're going to use that marginal cost curve, that average cost curve, average total cost curve. And we're going to look at marginal revenue and perfect competition. And we'll do that, and then we'll take it and relax our assumptions of perfect competition and look at other types of competition, monopoly and oligopoly, and monopolistic competition. We'll look at general equilibrium and welfare, and we'll just keep going forward. So that is the plan. So please be prepared to look at Chapter 8 next week, competitive firms and markets. And that's going to use everything we've talked about so far in terms of firm behavior to help us understand why we expect to see what we expect to see in terms of short run profits and long run profits. It's going to get in this idea of economic profit, opportunity cost, economic cost, and the decision to stay in business or not, which is actually pretty relevant right now. So let me know what questions you have. I'll get everything set up on Canvas, and I will see you all on Monday. Thank you.